We're going to be looking at Chapter 6, Part B, Radical Functions and Rational Exponents. In Part A, you learn to simplify expressions involving radicals and fractional exponents. Now you will apply what you learned to solve radical equations and graph radical functions. So we're here on page 416 in your textbook. If you go down to the bottom, you'll see that we're looking at several big ideas in sections 6.5, 6.6, 6.7, and 6.8. Our first big idea is equivalence. To simplify the nth root of an expression, what must be true about the expression? Our second idea is solving equations. When you square each side of an equation, is the resulting equation equivalent to the original? And number 3, functions. How are a function and its inverse function related? In 6.5 Part 1, we will be looking at solving square root and other radical equations. Please write down the following sunshine state standards. The first sunshine state standard means that we will solve equations that contain radical expressions. 2, we will convert between rational exponent and radical forms of expression. Please pause this video if you need a moment to write this down. All right, what's the objective for this lesson? Please write the objective down. To solve square root and other radical equations. Let's take a look at the getting ready. You are a passenger in the car and you're using a cell phone that connects with the cell phone tower shown. The tower has an effective range of 6 miles. How much time do you have to finish your call? Justify your answer. We'll be talking about this problem more, and we'll be discussing the fact that cell phone towers will need an effective 6-mile range, which means that it's going to have a radius of 6 miles. Along with this 3 miles, it's going to form a triangle. So we'll be talking about how far the car can travel in this triangle. All right, a radical equation is an equation that has a variable and a radicand, or a variable with a rational exponent. If the radical has an index of 2, the equation is also a square root equation. In this lesson, assume that all radicals and expressions with rational exponents represent real numbers. So our lesson vocabulary in this section is the following: radical equation and square root equation. Please write down the words and write down their definitions. So what's our focus question? How can you solve radical equations? Well, to solve a radical equation, you're going to need to isolate the radical on one side of the equation. And then after you've isolated the radical, you're going to raise each side to the power based on the index of the square root, or the root equation. So let's go ahead and look at problem 1. What is the solution of 5 plus square root of 3x plus 4 equals 10? So let's go ahead and write down the original equation. Now, to isolate the square root, you're going to need to subtract 5 from both sides, which leaves us 5 on the right side and eliminates the 5 on the left side. Then we're going to square each side because the index here is 2. The inverse of that is going to be 2. Make sure you write that 2 on both sides of the equation. Finally, you're going to simplify. Then, subtract 4 from each side, and that will leave 3x equals 21, and divide each side by 3, which leaves x equals 7. So, the solution is 7. Now remember how every time we use the square root sign, we usually have a plus or minus. But in this case, you do not have a plus or minus because you are squaring both sides of the equation, not taking the square root. If you've got it, write down the question below. What is the solution of square root of 4x plus 1 minus 5 equals 0? And solve it. Please pause the video so you can work this out. we're going to be looking at problem number 2, solving other radical equations. To solve equations of the form x to the power of m divided by n equals k, you're going to need to raise each side of the equation to the power n over m, which is the reciprocal of m over n. Notice if either m in the numerator or n in the denominator is even, then x to the m over n over m equals the absolute value of x. Let's look at problem number 2. Problem 2, solving other radical equations. What is the solution of 3 parentheses, the quantity x plus 1 to the exponent of 2 over 3 equals 12? What do you know? You know the equation, you know the power of the exponential expression, which is 2 over 3, and you need to solve it to find the solution for x. What's our plan? Isolate the exponential expression, use the inverse of the power to simplify and solve the equation. Alright, let's go ahead and write down the original equation. Notice that to solve the part with the exponent, you're going to divide both sides by 3. Then to get rid of the exponent of 2 over 3, we're going to use the inverse. We're going to raise each side to 3 over 2. Next, we're going to multiply the exponents, because when we raise it to a power, we're going to multiply. So 2 times 3 is 6, and 3 times 2 is 6. 6 over 6 is 1. So that simplifies over here to x plus 1. Notice we're going to use a rule up top. Since m equals 2, and that's even, you are going to put the absolute value signs. Now, how did they get this number 8? Let's go ahead and follow over here on the right. 4 to the exponent of 3 over 2 equals a square root of 4. That 2 becomes your square root, and the 3 becomes your power. What's the square root of 4? Well, that gives us 2. And so 2 to the third power, remember, is 2 times 2 times 2, which is 8. All right, now that we have an absolute value, we're going to need to split it up. Notice that the first equation is exactly the same, but there's no absolute value. And the second equation is almost the same, but the 8 is now negative 8. Solve each equation and you get x equals 7 or x equals negative 9. All right, now comes the really important part. Check to see if you've got these equations right. Substitute the value of x in the original equation. So we're going to put 7 where we saw x above, and then we're going to work each side out individually. And then on the right side, we substitute negative 9, and we're going to work each side out individually. So let's go ahead and work it out. 7 plus 1 is 8. Remember, if we're going to rewrite it as a power of 3, 8 is 2 times 2 times 2. So another way of writing it is 2 to the third power. And then notice the 3 on the inside and 3 on the outside are going to cancel because remember we multiply these. So we're left with 2 to the 2 power, which is 4. Exponents come first. Exponents times your 3 will give you 12. So it does check out. Let's try over here. Negative 9 plus 1 is negative 8. Now that means negative 2 times negative 2 times negative 2, which is negative 8. So negative 2 to the third power. Remember the 3 in the numerator and the 3 in the denominator cancel out, so we're left with negative 2 squared. Negative 2 times negative 2 is 4, and 4 times 3 is 12, so this also works out. So in this case, there are two solutions, 7 and negative 9. All right, what is the solution for this type of problem? It looks more complicated, but we're going to stick with the same steps. We're going to take the original equation and rewrite the radical using a rational exponent. So if we've got a 5 here, remember the 5 goes in the denominator and the 3 goes in the numerator. So we're going to get x plus 1 quantity to the 3 over 5. All right, now we're going to solve this equation. So that means on both sides we're going to subtract the 1 first because we want to isolate this part. Don't get rid of the 3 first. Make sure you get rid of the 1 first. So we subtract 1 from both sides and we're left with 24. All right, now we're going to get rid of the 3. How do we get rid of the 3? We're going to divide each side by 3. So 24 divided by 3 will give us 8. And remember, how do we get rid of that exponent? We're going to use the reciprocal, which is 5 over 3. Make sure you write it down on both sides. Okay, when we multiply the exponents, we get 15 over 15, which is 1. And 1 is just the same exponent as writing it without. So we're going to write it without. We're going to write x plus 1 equals 32. Oh, what's different here? M and N are both odd. So there is no absolute value sign here. And we're going to go ahead and finish out the steps by subtracting 1 from each side. Now, if you're a little confused here as to how we got 32, let's backtrack for a moment. And 8 to the 5 over 3, we're going to go ahead and rewrite it. Remember, the 3 goes on the radical as the index, and the 5 goes outside. What times what makes 8? Well, we practiced that. We know that's 2. So then we're going to take 2 to the 5th, which is 32. The solution is 31. All right, if you've got that and you have no questions, there's a next question on the next page. You can go ahead and work out these two got it questions. All right, our last problem here is problem number 3. We're going to go ahead and apply using radical equations to a formula. In earth science, for a meteor crater in Arizona, the formula D equals 2 times the third root of V divided by 0.3 release the diameter D of the rim in meters to the volume V in cubic meters. What is the volume of the meteor crater? All values are approximate. So let's go ahead and look at this picture. The information they gave in the picture is 1.2 kilometers. And we've got a formula here, so we know we're going to plug it in. 1.2 kilometers is going to be either D or V. Let's see which one comes out. Well, it's in meters. I guess we can go ahead and convert kilometers to meters. How do we convert kilometers to meters? It says right here, 1.2 kilometers would be 1.2 times 1,000. And so we get 1,200 for D. All right, 1,200 equals 2 times the third root of V over 0.3. And we're going to divide both sides by 2 to get the radical by itself. We're going to remove the 2 by dividing. And then to get rid of the cube root, remember we're going to put a 3 on both sides, and the 3 will cancel out here, so we're just left with the inside of the radical, which we call the radicand. And then that division side, to divide, the reverse of the division is multiply, so we're going to multiply both sides by 0.3. And you type this into the calculator. So let me remind you how to do that. Please type 600 to the third power first, because that's our exponents, and then multiply that by 0.3, and you should get this number. Finally, just to make it really nice, we're going to write it as a full sentence. The volume of the meteor crater is about 64,800,000 meters cubed. And just a reminder, if you don't know where we got that meters cubed, up here it said the volume is in cubic meters. All right? Okay, if you've got it, go ahead and work out that got it question. Suppose the diameter of similarly shaped crater is 1 kilometer. What's the volume of the crater? Use the formula given in problem 3. All right, to sum up everything that we've done today, look at the focus question. You should have written this down earlier, but the question is, how can you solve radical equations? And let's think back. To solve a radical equation first. Isolate, that means put it by itself, the radical or the exponential expression. Then you're going to raise each side of the equation to either the power suggested by the index of the radical or the reciprocal of the exponent. All right, that's it for 6-5 part 1. And I hope you enjoyed that lesson, and I will see you tomorrow.